Okay guys, let's look at what would happen if we put something in orbit around the Earth. We did one on the paper that was around the moon, but I don't want to do that exact same problem. So, what if we have the lovely Earth here, alright? This is Earth. And I want to put something into orbit around it, just right around the surface of the Earth. So like, literally not more than like a foot off the Earth. Well, if that's the case, we know a couple things. The first thing we know is that the centripetal force is equal to the net force on the object. Well, if this thing's just right above the Earth's surface, we have to assume, in this case, that the Earth has no air. So let's just assume that for a minute the Earth lacked an atmosphere. Maybe it's a planet the size of Earth with no atmosphere. That works too. But the only force acting on it would be what? The only force acting on this object would be the force of gravity pulling it in toward the Earth. There's no other forces acting on it. So the centripetal force, since it's equal to the net force, has to be equal to the force of gravity. If that is the case, then that means that mass times centripetal acceleration has to equal mass times the acceleration due to gravity. Masses cancel, and we're left with centripetal acceleration equals g. Or, another way to write this is AC would equal negative 10. Alright, negative 10 meters per second squared. Okay, well we can just call it 10 because it's going in a circle and there's no need to have negatives in the circle. So we'll just call it 10 meters per second squared. That is our acceleration, our centripetal acceleration. So if that's our centripetal acceleration, then what we know is that centripetal acceleration is equal to v squared divided by r. Well, AC is 10, v is unknown, and r is 6.4 times 10 to the 6th meters. So we're solving for v. So we do 10 times 6.4 times 10 to the 6th meters, and we get 6, 4, 1, 2, 3, 1, 2, 3, I think. Hang on. Should be 6 zeros. Yes. Okay. So we've got that. And that's equal to v squared. So then we square root both sides, and we find that you would need to have an object moving at 8,000 meters per second in order to have it orbiting just above the Earth. That's very, very fast. That's 80 football fields every second. Okay? So hopefully that helps y'all out. Have a good day.